We'll be talking in the context of CloverDX because this is what we provide and how we help our customers do exactly that. How we can make sure that they can build efficient and easy to use data pipelines that work well for their technical teams as well as for the data consumers or data providers, which are usually their users. So first, a little bit about CloverDX. I'm not going to spend too much time on that. Just a couple slides so that we all have the context. So CloverDX is a platform that we've been working on for about 20 years. It's a data integration platform that allows you to do pretty much anything you want to do with data. Right? On one hand, we provide the platform itself that can solve real-world data challenges. We've been on the market for quite a while, but we also provide in-house expertise. We have a team of skilled data engineers who can help you build your solutions the way you need them to work. We can provide trainings and basically anything you need to do with data. We proud ourselves basically in making sure that you succeed whatever your challenge is, whether it's simple or complex, we are always there. And most of our customers are very satisfied with how we work. Almost 99% of our customers rate us as highly satisfied when we do customer experience polls. As I mentioned, we've been on the market for quite a while. I'm going to go through this and just a couple of logos so that you can see that really we do have customers from all kinds of parts of the world and of different sizes. We work with startups that are really fast moving. They often tend to break things because they need to build their products and make sure that they do that efficiently. But on the other hand, we work with large, heavily regulated companies, mostly in finance industries and so on, who have very different problems than the smaller organizations. Their problem is typically related to regulation and just having so many things to do. So let's talk about the overall scenario that I would like to discuss today. When you imagine what a typical data integration job looks like, without kind of looking too low level into what kind of tools you have or what you are going to do, you always have, let's say, 4 stages. In some projects, these stages will have different weights, and it might be more on the ingest side or the mapping might be more complex, but there is always these 4, let's say, steps that you need to do in order to get your data from where it is to where it's supposed to be. The first piece that you will have to work on is the data ingestion. This is a very challenging step because oftentimes you'll be working with many different data sources. You'll need to figure out how to connect to them, how to make sure that your data access is secure, which is especially important if you are working in cloud. And you'll have to do it in a way that scales into the future, whether you will be growing the data volume because you expect to, for example, onboard more customers or simply handle more data because your business gets larger, or you'll need to be able to handle different data layouts because data sources change. Right? Sometimes your API that you are reading from changes, or your customers can give you files, or in general data in different format than what you agreed on because their business evolves as well. So the first step is just getting the data from where it is to your platform. Then you have to do something with it. Right? Very rarely you just need to grab the data and dump it to the target and you are done. Usually there is some sort of business logic that lies in between. Sometimes it can be very simple. Really, for example, if you are building something like a data lake or something similar, the logic is fairly simple. Get the data, grab a little bit of metadata around that and load everything into storage. But still, there's a logic to collecting the metadata and so on. And what you want in here in the mapping, if you do something more complex than just straight up load, is that you want users to be in control of that. And by users, I mean people who understand the data. So not your IT, who, well, of course, they have to understand the data, but they are not the ones who the data is for. Right? The data is for your customers or maybe for your internal teams if it's some sort of internal use case. So you want your users to have some say in how the data is mapped from what the data source provides to what they need. Around the mapping, maybe before or maybe afterwards, in here we have it drawn afterwards, you need to validate your data, which means that you need to make sure that whatever you process makes sense. Well, this might seem weird, especially for data that's often generated by something, like even in like marketing, for example, often you'll see data that comes from platforms that track clicks on your web pages and so on. And you might think that it would be weird to validate that, but it still pays off to validate even data that's provided like this. So data quality often tends to be a problem, and you need to make sure that, again, your users understand uh, what kind of validations you do, what kind of data you can accept, or what kind of data you can't accept. And of course, you need to provide them information about when the data is invalid, generate some sort of report, or at least a simple dashboard that gives them the ability uh, to track the overall health of your process. And finally, the last stage is delivery of the data, uh, which basically means you need to present your data to the end users. Maybe it's loaded to the warehouse and they have some sort of interface to look into that. That's one way of doing that. But in many cases, this is not what you want. You want your users to, for example, be able to directly connect with some sort of reporting tools like Tableau, or maybe get reports directly, because that's the purpose of your data integration jobs. You might want to provide them with some sort of API so that they can connect other tools to it, or even web applications that help them work with data directly. So there are many options for all of this, and we'll talk a little bit about how you can do that with Clover. So let's have a little bit better look at the first stage, at the data ingestion. As I mentioned, this is the first step, right? You always have to load data from somewhere. And what's interesting over the last couple of years as we worked with our customers is that the landscape of systems that our customers work with is getting more and more complex. Even like medium-sized organizations who do not have too many employees or too many, well, you might say systems, still get to have dozens of systems to integrate. When you think about how cloud applications tend to, let's say, grow within the organization, and every different user needs something different, and oftentimes they get it because it's not expensive. It's easy to pay a couple dollars a month for a tool that makes your job easier. But what happens afterwards is that you end up with a lot of systems that usually have their data in their own silos, and if you need to do something with it, for example, provide some sort of unified reporting on top of the whole thing, it's always complicated to get the data out of all of these systems. And especially when you look at cloud applications, they tend to change very frequently because the nature of the businesses move fast, so that people keep buying you, because if you don't have new features, they are not going to do that. So we often see changes that add new features or even break existing APIs and so on. So the landscape is always shifting, and you have to stay in touch with that if you want to provide some sort of unified use case. Oftentimes, you'll also, especially in larger organizations, hit with a lot of legacy systems that frequently have just files of different types, or even more complex kinds of storage, right? The simplest ones, like databases, they are still pretty common, but usually they are fairly easy to integrate. So that typically is not a problem, even if you have quite a number of different databases. So complex landscape, and you somehow have to make sense of that and make sure that when you are loading the data, it gets loaded into your systems properly and without issues. And there are few things that you want to accomplish when you are ingesting your data. First, you want to have the process that's stable and that works even across failures. For example, if you are loading data that sits on a remote system, it can be quite common for the system not to respond in a way that you want it to. For example, internet might be down, might be slower, or of course, it might have changed in between. So you need to make sure that your data process is stable, automate it as much as possible, and it can grow in future. Now, you also want to make sure that your business users, who are typically not as technical, they are not developers, can interact with the process in some way, because oftentimes it's their data, or it is the data they are interested in. So they will know something about it. They might want to give you some instructions about how to load it. And you can do it kind of old school. They write specification, 3,000 pages long Word document that gets passed from department to department, and in 5 years you have something implemented. But this is something that doesn't really happen, or at least people don't want that to happen these days, because they want things faster. The business moves much faster than the usual cycle of request, validation of request and implementation and so on. So you want the process to be somewhat accessible to your end users. And One thing that's important but often forgotten is that you should design your process in a way that you can reuse it as much as possible. Even when you are, for example, working with different source systems, you still want to make sure that the overall process that your data flows through is fairly similar to as much extent as possible, so that whoever ends up doing something with that process in the future doesn't have to learn new, unique way of handling data for every different system that you have. Obviously, there will be differences if you, for example, need to connect with an API and with a database, and you work differently with those. But overall, you should still focus on having the same steps. For example, loading the data into a staging system and then doing something in stage and moving to further process down the line and so on. This is especially important if you are doing client data onboarding, where your business depends on being able to efficiently and quickly onboard as many clients as possible. And for example, if you imagine, let's say you are an organization that provides something like a marketing services, right? So you need to process data from your clients. And in many cases, they will be able to provide you standardized inputs, which is fine. You can handle those, and over time, you'll collect processes that can work with data with different systems that your customers have frequently. But there will always be someone who is an outlier. Either they have customized something very heavily so that it's very different from what you would expect, or they have something you have not seen before, either because it's a new system or something very old, right? So always make sure that you can reuse as much of your pipelines as possible, because that saves you development time, and then it's much easier for the support and related roles to handle when it's running in production. One of the examples I have in here is a legal case management system. This is something that we've done a couple of years ago, where the requirements were pretty much what I mentioned before. And you need to handle data in variety of formats, because the customers can provide you data in whatever they need, and you don't want to prescribe to them. So you want to make sure that when you are ingesting your data, when you are starting the ingest, you can scan the data without having to somehow tell the system what the data looks like. So automatically scan, figure out what it is, and then load it to the target. Then the second step, as I mentioned, reuse as much as possible. So whatever the source data is, we load it into staging database. This is a direct load, so whatever layout the data has in source, we replicate it in the database. If the source is a file, we create a table. If a source is a database, we create a matching table in our database, and so on. So every time you want to implement something that works with the data afterwards, you do it on top of a staging database. That provides you unified interface. It's easy to use. You can query that. You can see the audit of data if you do it properly, and so on. And of course, the last point, in this case, one of the problems was that the source systems were not very reliable. So the whole approach was to optimize this for retries, so that if something happens, it's not a problem, right? If you have a file that's half processed, or database table where you know that you have to load certain volume of data and you finish halfway through because the internet goes down, then you still need to be able to continue. And designing the process with this kind of thing in mind requires a little bit different thinking, but then allows you to have something that's very resilient to failures, whether the process fails on your end, for example, server crashes or something like that, or you can't access the source data. You just retry and nothing happens, right? Or nothing bad, actually, at least. And of course, if you are doing this, and this being the legal case management system, you need to have a full audit of everything that happens with your data. The initial step of that is auditing the data as it goes into stage, and then every subsequent step of the process gets its own audit where you track what you've done with the data and whether it was successful or you had to retry, and so on. So when you look at the process from a very high level point of view, and you are getting, in here I have your own files, but it can be pretty much anything. So you fetch your source data, scan the structure, then create your target table. If you've seen the data source before, you already have the table. If not, you just create a new one. Then you load archive files, right? This doesn't apply for databases because there is nothing to archive, but you might need to archive whatever you've read, and then you update the audit log. Success, failure, you track the number of records that are valid, invalid, and so on. And all of that is powered by a database that keeps track of your metadata. So what do you have, the layouts of the data that you've processed, the list of those files, their statuses, timestamps, and all kinds of things that you need to have in even very basic audit log. When you look at implementation in CloverDX, I have a screenshot from the actual project. This is the top level job, or at least one of the top level jobs that are there. And you can see it's really that simple, right? This is the one that processes files. So it looks at input files, then you create the metadata for that, and then you create and load tables. And how this is implemented actually doesn't matter that much, right? What's important is that you have something that's very easy for the people who work with the system to look at, right? So people who know Clover can very easily look into something like this, and they immediately see what it's doing. Whether create metadata is implemented in one way or another doesn't really matter. From just this kind of picture, they know what it's doing, and if they know the use case, what they are trying to accomplish, they will know how to work with it, and how the whole system can be supported. If you look a little bit deeper, this is more expanded view, where again you are listing the files, and this gives you the ability to look at the metadata as it was ingested into the system, right? And you need to scan your source files, and once you do that, you need to verify whether you've seen the metadata before, or you need to update your table. So we still have the create metadata in here. We have the list of processed files, so that if we retry or someone uploads the same file twice, we ignore that. If the metadata already exists, right? If we already seen that kind of data source, we just go straight. If not, we produce a new one and then load it into a table, creating a new one if needed, and it can produce the audit log. So as you progressively go deeper into the system, you reveal more and more details about how it works, but still keeping the same high level approach. All right, so that's the ingestion. Let's have a look at the second step, the mapping. This is an interesting problem, some might say, because oftentimes it's quite challenging, right? So how do you figure out how to map your data source to the data that you need? And there are many different variants of the same thing. For example, if you are ingesting customer data into your platform, you need to understand what kind of data customers provide. And then obviously, your own internal format, what kind of information you need. So, that can be a little bit easier. But if you are doing integration for something like a warehouse, you might need to map data in more complex ways. For example, even merging data from multiple systems into one, so that you can produce one data mart, right, that merges data from, let's say, finance, accounting, and your sales team, so that you get overview of how your sales are moving and so on. So one thing that you'll see when you are talking about data mapping is that the people who have most say about it are usually the people who can't implement that, right? So your domain experts, whether they are the data owners or the data consumers or your customers, they are always the people who know what is in the data and what you want to accomplish. So they typically know what the process needs to be, but they tend not to be technical. Obviously, you can have, if you have, for example, if you are doing client data onboarding, you can have two companies, and their developers can meet and figure that among themselves, but usually that's not a very effective process, because it still needs an approval from the business whether the mapping is correct. So the best way of doing that is to simply give your business users access to the mapping, because they know it. And then you get to a challenge: how do you do that? Right? Many times when you build your processes, they are going to be quite complex. Even if you use Clover, which is very visual and easy to work with, you don't want your business users to go directly into the system, because there will be a lot of steps that need to happen around your data that are not really the mapping. Right? They are the auditing, the movement of data around the system, making sure that it all works, reporting, reconciliations, and so on. And they don't need to be involved in that, but it just complicates the view. So how do you represent the mapping in a way that makes it easy? And there are many different ways. Right? On one level, you can, of course, use tools like Clover. If your users are are technical enough, or if the use case is simple enough that you can use just the built-in interface. But oftentimes they will ask for something different. And this is what I've written as a second bullet in here, which is usually the most feared platform of all, and that's an Excel spreadsheet. Because everyone has it, everyone knows how to use it. And it can be, well, let's say, abused a little bit to do all kinds of things, right? Oftentimes, even like business rules for your process will be specified using an Excel table, and so on. So your users will know how to use this, and they will frequently ask for some sort of interface that resembles Excel. Even if they don't ask for Excel specifically, they might ask for a custom web application that behaves like a spreadsheet where you can edit tables with different things and so on. Obviously, you can do code or even data modeling tools, but that all requires different kinds of users, and they are usually less common. Even if you talk about something that tends to be fairly high level, when you use data modeling, it still requires more technical skills than many data owners or business users have. So I'll talk a little bit about the Excel and how we handle that in Clover, because this is something that actually comes up very often for us when we talk with our customers. They simply ask for this, right? So how do you tell us the rules for our mapping? Well, we want to give you an Excel file. And one of the ways of doing that is obviously, you have a bunch of developers, they sit in and they code it. They look at every line in Excel or whatever the format is, and they write it. But that's not what you want. You want to automate that. One of the use cases where we did just that was mapping from HL7 data to an internal data structure. For those of you who don't know, HL7 is a format used in healthcare. It's a very complicated data format. You can imagine it as let's say XML or JSON, although it doesn't look like that, but it has entities that are nested into each other and can be several levels deep. There are thousands of different entities defined in the standard, and different organizations work with them differently. So this all presents changes or challenges on multiple levels. On one hand, the file format itself is very complicated, and it's kind of old school with multiple different types of records in the data. So many modern systems do not know how to handle that really, because they are not meant to work with data like that. But also everyone uses the standard slightly differently and implement it differently. So there are changes in systems, right? One property can mean something slightly different in each application that you work with. So this all requires multiple levels to work with. And this is pretty much exactly what we implement. And when we thought about how to do this, we figured out that on the first level, the first thing that you want to do is just look at the file on the lowest level and verify whether it even matches the standard. If it doesn't, you report the errors in some way. In this use case, we used Kafka, so it wrote error messages into a Kafka stream, and the customer already had a platform to look into that. So we didn't have to build it; we just needed to provide errors in certain format to Kafka. So this gives you the low-level view of the data. Your business users understand that because they know when they receive certain object from HL7 file that it will have certain properties, and they know what to do with it. But then, because they were working with multiple different clients that provided essentially the same kind of data, they had two challenges: how to make sure that the different systems that have different implementation of HL7 standard work, and every client has their own customizations. So even if they are using the same application, it's different. So we split it into two different levels. On one level, you handle differences between the healthcare applications that store the data on the customer side, and then on the second level, you add additional rules for client side customizations of each of those systems. So this tends to be reused very often, and the mapping in here is unique per client because everyone is slightly different. And all of that was configured through an Excel file. You had one for each source application, and then there were, let's say, smaller mapping files for client mappings. And when you combine that, you get a system that's robust, because adding a new application, new source system, just requires you to add a specification for this part. It's fairly easy to do because Excel file is not hard, even if it requires quite a lot of work. And the little screenshot you see in here is one part of one of the entities that's mapped there, and there can be hundreds of them. Right? So it's extensive mapping, but it's just a lot of work. It's not complicated in principle. And the second step is done in exactly the same way, except you provide the missing pieces, right? So what you don't get in here, what you are not able to map in here, gets mapped in here. And internally, these things, again, can report errors into the same Kafka topic so that you can see what happens with your data and whether it's working as intended. And in the end, you write it somewhere in here. It was pre-formatted into their internal format, which was a JSON file, or rather a JSON message, and it again went into a different Kafka topic. And so this kind of approach, where you give your business user something that's fairly simple, is very effective. The downside is that obviously we'll have to implement translation from this kind of specification into the mapping code itself. But this is something we have done several times in the past for different kinds of use cases. So we are pretty good at doing this efficiently. All right, let's look at the next stage about data validation. So data quality is an interesting thing. Oftentimes it's one of the last things that people think of, or at least one of the things that usually receives smallest fraction of the budget when you think about data integration, but it's often something that can cause you the most problems, simply because people don't think about it that way, right? And even if something is generated automatically, it can have problems, right? Not, there can be bugs in the software that produce the source data, or it's not complete simply because the source system doesn't have the data that you need, and so on. So the validation is really important, and it can happen in different stages of the process. And it's the most important when you are working with third-party data. When you are integrating your own internal data sources, you often have all of them under control to at least a certain extent, so you can fix it, right? And the most efficient way of fixing data problems is in the source system. When you own them, you can do it by yourself. But when someone else owns the source system, you might be getting data that's incorrect over and over again, because they can provide you, for example, incremental load of their customer data. And if there's a problem with their source system that doesn't work well for you, you will be getting the same thing every day, or however frequently you are getting your data. And again, in here, the interesting property is that the rules for what good data should look like, again, the business users know them. Right? There are some technical validation rules, like, for example, string is too long or something similar, that your IT will know. But the more high-level rules, those that are easily broken, are the ones that your business knows. So you need to ask them for how to deal with that again. And the approach can be pretty similar to what we've seen in the mapping exercise. You usually get an Excel file, and you somehow need to deal with it. And usually you generate some sort of framework that understands the way that your customers write their data quality rules, and then just work with that. What's interesting is, and again, something that sometimes people forget, is that you should make data quality an integral part of your process. So whatever you do with your data, make sure that it's good data. So you do that when the data arrives. As part of your data ingestion pipeline, you validate your data. You check whether it has at least some basic properties. You don't have to do too deep, low-level validation, but at least the basic stuff, whether it's complete and it's not missing something, so that you can reject your data early. Because the worst thing that can happen is that you get data that's of low quality or lower quality. Right? It doesn't have to be entirely bad, but it can have some of its properties broken. You get that into your downstream system. The further down the line you capture the error, the more expensive it is to fix, because it might happen that multiple systems that the data went through need to be updated, need to be fixed. In some cases, it's very hard to fix something, especially if you look into finance. Everything needs to be audited. So fixing the data in one system and not in the other will mean that your audits will not align, and then it's all kinds of complications come from that. And then once you validated your data on input, right, you just know that it's good enough. But as you are doing something with data, you should validate at every step. And then there are different ways of how you can implement that. You can either implement really complicated validation at the beginning that verifies everything, and then all data after a certain point is good, or you can do smaller and simpler validations in different steps depending on where the data goes to. This really depends on what your use case is supposed to do. In some cases, data is fairly simple and you can be pretty lenient. Right? For example, if you are processing a Twitter feed, then the validity of data, there will be some basic things like timestamps, usernames, and so on that you want to validate. That the data is fine, but whatever people write into those tweets doesn't really matter that much, right? You will probably analyze it with some sort of machine learning or something similar, and it will deal with the things that that make the message a little bit invalid. So just make sure that you validate your data at every step of the process so that you don't propagate invalid data downstream. And finally, let's look at the last stage of the process, and that's the deliver. This is interesting thing because many people don't really think about this as a separate step. The goal is to give your data to people who need it. And when you talk about this, often people just mean that, okay, so my data is, for example, for my sales team or for my marketing team or whoever inside the company needs to consume the data, or for our customers. But then there are other users that need data that relates to what you are doing. Right. So on one hand, you have what I call analysts, and in one word, so your customers, your internal teams, and so on, business users. But then you also need some data for management, right? Does the system work properly? Can we process data fast enough, and so on? This is typically very high level overview of your data, but you still need to provide something. Your support will need different kind of data. Your developers will need different kind of data. And this all needs to be built into your process. Some things you'll get, let's say, for free with your platform. Like, for example, for CloverDX, that means that you'll get all kinds of metrics about what your processes are doing, how much data was processed, whether it's failing, how long it takes, and so on. You get it out of the platform, and you can build reports for your management or for support or even for developers. But other things that are more specific to use case, like, for example, if you have more complex reconciliation rules, or you need to do some sort of more complex audit, you'll need to build that into your use case. So you need to be careful about thinking about this from the very beginning, so that you build it in a way that allows you to add this kind of data to your process, so that you don't have to do it, afterwards, which is usually more expensive. And there are different ways of delivering your data. When you ask your users, the analysts or business users will typically want to see the data in whatever they already use. So if they are business analysts, they use some sort of BI tool. They might want Tableau or something like that. So you need to make sure that your data gets delivered to Tableau. You might have people who have their own web applications, so you need to load into wherever the web application is looking at, or build reports in a variety of formats. Again, the Excel being very popular format here. And so every user will have different requirements for how they want to consume your data, and you need to make sure that you satisfy those requirements. In CloverDX, we have all kinds of features that help you with that. You can, for example, use data apps for your really high-level users that allow them to control the processes and even see the data directly. As I mentioned, we have all kinds of features that allow you to monitor your data process, so you can provide dashboards to your management or support team and so on.